Alright, so in the last video, if you guys have been following along, I installed a Volvo 2-speed fan. So I was able to cram this monster in here on the passenger side since my mechanical fan was shot, and I decided to go dual electrics. So it fits in there, it looks pretty nice, and we got some clearance, so I'm happy about that. Now comes the fun part of wiring. Now, the stuff that I'm going to show you can work for any 2-speed fan, so if you got yourself a Taurus fan or, any other kind of fan like that, or even just 2 electric fans in general, methods like this will work for you. Now, I lucked out with this Volvo fan. It comes with a relay pack that does, all the hard work for you. All you got to do is ground the 2 yellow wires for high and low, and that's it. So we need a way to ground those wires, and I want this to happen automatically. You could set this up where you run the low to the stock fan switch, and then you put a switch inside the cab that goes to high, so that way you could control which one goes on or off or whatever. But I'm going to use a dual temperature switch to control the fan automatically, so I never have to touch it and it just runs by itself. So we're going to use a BMW Dual temperature switch to turn this on and off. So let's go head out to the junkyard and see what we can find. Next on the shopping list today, a Beamer. This old BMW is a 1995 some number I don't really care about, a 525i or some shit. I don't know, the fuck are you? Yeah, 525i. So this one's got the backwards hood on it, so we go hoi! And you think, oh, well, there's only a mechanical fan in here. What the hell are we doing in here for? Well, let's come to the passenger side. And, oh, look at there. Nice. This is a 2-speed temperature switch. We're going to use that to control a Volvo fan. But I want to make sure it's the right temperature. There's 2 different temperature ranges. One is lower, one is higher. And with the higher one, that's like 91 to 99 C. It's 196 to 210. So let's take it out and take a look. Oh, she wasn't too bad. Just a quick little turn with your nut fucker and she comes right out. So here's our main prize. If we take a look at the readings, come on, you can do it. Down at the bottom there, BMW 91 degrees and 99 degrees Celsius. That's the bad boy we want. So this little bum snuffer gives us a 2-speed on stuff. So yeah, that's what we need. Now, if only I could find the frickin' electrical harness that plugged into the damn thing. Yarg. Where's she be? I found her hiding. She was hiding down here. Someone took, I guess, the headlight front panel thing out. But it'll be somewhere off of this wire. So that's what we're looking for. Cool. Thank you, Mr. Germany. Okay, so now it's time to make an adapter for our temperature sensor. Here's the old one, and here's the new one. As you can see, there's quite a big size difference there. This guy right here is a 22mm, and this is a 14mm. They're both 1.5 for the thread count. So, I figure since the bottom of the radiator is the part that we care about, that's the output side, we want to know how well the fans are working, so we want to put our temperature sensor on the output. So we're going to have to make an adapter. The best thing would be if you could find a 22 by 1.5mm pipe plug out of brass or something like that. If you're in Europe, you're in luck, because those things are frickin' everywhere and they're cheap and they're easy to find. If you're in America, good frickin' luck. I've tried everywhere and nobody's got this size at all. It's very difficult to find. So, since this is an old one, I'm just going to hack this one off and use this as our adapter. And then that's just what's inside. Some kind of weird crap. So I took all the crap out of there. And it's very hollow. So hollow that I don't think I'm going to be able to use it. Now, I went online, and this is the closest thing I could find anywhere to what I wanted. Now, the nice thing is pressure washers use 22mm threads, so it's a little easier to find these sizes. I bought this off eBay, and it said 22 by 14 by 1/4 inch. I don't know what all those readings meant. The outside over here is 22, so that's good. So we got a 22 by 1.5 outside, so it'll fit in the radiator. This size up at the top, though, is just a little too small for what we need. But that's a good thing, because you don't want bigger. I could find plenty of 22 by 18 or 22 16s, but no 22 14s. So this is real close, but it doesn't quite fit. So what I'm going to do is drill this out to 1/2 inch and then tap it. I got a lovely tap set I just picked up. Over here are 14 by 1.5 tap. And these have some funky Zarg something coating on them that hopefully makes them last longer. So, okay, so I got some measurements here. This is the basic concept, is what we're doing here. We got threads on the outside. We got threads on the inside. We're going from a 22 to a 14. Done some conversions here to figure out what size they are in inches and what we're going to need. So we're going to need a 1/2 inch hole in order to use this 14mm tap. Now we take our tap and tappy tap tap. Okay, so let's see. Look at that, huh? Nice. Okay, so it looks like the 14mm that was in the description was the inside diameter of this fitting. Because if you notice, the threads kind of stop. They don't really go too much further. And this fitting, this temperature sensor fits right in there. So, cool. Alright, so here's our temperature sensor. You can see the thread sealant. So I tightened those both together as best as I could. So that sensor's ready to go. Now, down here, I took out the secondary electrical fan to have room. So you can see that tiny little baby. And right there is our radiator fan switch. So I just broke it free, and I took the connector off, so it's ready to go. I have a drip pan underneath, waiting for all the coolant. Now this part is going to suck a little bit, because I have to take this sensor out and then quickly put the other sensor in. Now this is definitely two-handed. The faster you can do this, the better, because you know, the less coolant you lose, the better. So this will be a nice little speed run. Make sure you got everything ready to go and you can put everything in. And just for shits and giggles, does this even fit? It should fit in there, I hope so. Alright. So, I got the switch in. It was a bit of a pain. I was able to switch it real quick, but the problem was the airbox was getting in the way because I got this little snorkel fitting. If you don't have a snorkel, this should go a lot smoother for you. And this is also a good reason why you don't want it to stick out much. Now, having one where the part threads into the radiator, having a much bigger flange there that'll actually cover the whole surface is better. So if you notice, I just put some thread sealant on there because I figured this was going to happen. So I just put some thread sealant on there and tightened it up, and it should hold okay. So I'm not super worried about it. Hopefully there's enough clearance there for the connector to fit on the back. And if that's so, we can wire it up. So we just got these 3 wires. So now that we got our adapter made, we can focus on the wiring of this wonderful switch. So I did some testing to figure out what we're looking at. So the first part here, this is the XJ fan switch. So I tested this one and it came on at 193 degrees and it shut off at 162. Now in the BMW, we got a low and a high, so I had to test both of them. On low, it comes on at 190, so only a couple degrees less than this. and it shuts off at 159, which is the same. So this one activates only slightly lower than this one, which is fine. For the high doesn't come on until 211, and it doesn't shut off till 183. Now, where I'm mounting this, I'm thinking about putting this on the output side, and I'm hoping that that's not an issue. For the low side, that's fine, because that's what it already was. And for the high, I mean, I guess what I'm going to do is I'll have the fan connected to the high, the auxiliary fan, because I have a 2-fan setup. So I figure on low, it'll just be the 2-speed Volvo on low, and on high, it'll be the high-speed Volvo and the second fan. So it'll be 2 fans on high, 1 fan on low. Let's take a look at the BMW side. So it starts out over here. You get 12 volts into the fan. All right, so this is the whole relay box, and you got 2 outputs to the fan. You got your low speed and your high speed to the fan, and the fan's grounded. Now, the fan speeds are activated through coils because this is a dual relay pack from the BMW switch. So we have 1, 2, and this one goes to ground. So this part of the switch is grounded, and then when 1 turns on, the first coil turns on, flicks this closed, and low speed turns on. And then when the second one comes on, with the BMW, the 1 and the 2 are both on at the same time. You can't have the low and the high being powered at the same time because it'll overheat the motor. But the nice thing about the Volvo relay pack is it does that switching for you. If you notice, the coil on the low side is actually connected to the off status of the high relay. So what happens is when this coil goes for the high side, it'll actually take the power off the first one and put it on the second one. So it automatically switches it for you. So with all that, we're all grounded. So this works fine for 1 fan. And for our second fan, we're just going to tap the ground relay into here. So just to reiterate, if you're only doing 1 2-speed fan, then it's really easy to hook up. You just take your 2 trigger wires from the Volvo relay pack, run them into the switch, ground the switch, and you're done. So it's really simple. Now, all this stuff over here, the way this is set up currently, it'll run whether the ignition is on or off. So if you want to make sure that the fan only runs when the key's on, like most fans do, you'd want to make your own secondary relay to turn this on and off. And the way that this diagram has it set up is probably the safest way you can do it. The 12 volts from the battery is fused, which goes into the switch side or the high side of the relay to turn the fans, to allow the fans to turn on and off. And the coil side of the relay is switched from your 12 volt ignition source. So if you can find a 12 volt ignition and ground the relay there, when you turn the ignition on, this will flip on and allow the fan to turn on, but it won't turn on unless the switch also turns on. So by doing it that way, you won't worry about killing your battery or anything like that. Okay, so now we know how to hook up 1 fan, but now let's take it up a notch and figure out how we can hook up 2 fans to 1 switch and get it all to work right. This is where the interesting part comes in, so hang on. So, how do you figure out the wiring? Well, first we have to look at what's in the Jeep. So right now, our temperature switch right here is in the positive inline side. So from the ignition power, this switch is what cuts off the power to the relay coil. And then when that switch turns on, then power can flow through the coil to ground, and then this side, the high side of the relay, can flip and then turn the motor on. So what we're doing is taking this switch out of the loop, and in order for it to work, we have to jump this, but we'll have to do something else. The weird thing with BMW and Volvo and all them is that they use grounds. So it's ground activated instead of positive activated. So we can't just put the switch in place of that one or we're going to have issues. So this is where my diagram comes into play. So we have our stock XJ fan relay and our new relay pack. We got our 2 wires that go to the motor over here. We got our 2 yellow trigger wires that go to the BMW switch, and we got our red positive. So what I'm going to do is we're going to, like I said, we're going to jump that radiator switch so that it just goes 12 ignition straight to orange for this relay. So this is always getting power now, and we're actually going to take the black that comes off the coil and put that into the high side of the switch. So now it'll be ground switched instead of positive switched. So it should be pretty easy. Now what does that mean on this side? Basically our brown is going to be the ground, our purple is the low speed. So purple is going to go to our yellow-white wire, and black-white is our high side. That's going to go to the regular yellow wire, and it's going to get the black from our relay. So we'll just have 2 wires on the one. Okay, so I'll give you a quick update. So all the terminals are soldered together. So we got our negative, got our positive hiding over there. I extended the 2 yellow wires for the fan. So we got a blue and a black. And they run over to the switch over here. Okay, so we got our switch all wired up. So the brown is the ground. The purple is the low side for the blue. And the black with white stripe is the high side, and that's got 2 wires because it's got one for both sides. One for the Volvo fan and one for the regular fan. So the one that goes to the regular relay, this relay over here is our fan controller. So what I did was found the ground, and since I replaced this socket before, we're going to have funny colors. So the green one was our ground, so I cut that and ran that to the switch. And then the black one that's coming from the switch now goes to ground. So that's how all that works, if any of that makes any sense. So we got 2 wires coming here that go on the switch, 2 wires that come there going on the switch, and everything is all grouped together in this little dude. So we plug that in, and we should be rocking and rolling, almost. I just got to make a thing for that. I got to jump that. And I'm just going to use the old connector that was on that thing. So I'm just going to solder these together, plug that in, and she should be ready, Freddy. Alright, so here's the jumper I had to make. Just soldered the end there. I'm going to heat shrink it, and that'll complete the circuit for the relay. Alright, I was having some clearance issues with the airbox because of how long this adapter is and the snorkel, so I just had to space the airbox up in the front with 2 thick washers, and that was just enough to get the clearance that I needed. So now that the airbox is tight again, I can put the air filter up on that shit, put in the regular fan, and I think we're done, honestly. I just gotta connect the terminals up. Cool! Alright, so we're all cleaned up and everything's looking pretty good. So here's the final install of the fan. See, just chilling in there. Got the relay pack hanging there off that tab. Got our 2 battery terminals hooked up. I got the wires in a loom, and they run across over there. Everything's out of the way and cleaned up and looking pretty good. Alright. Well, it seems like it works, so that's cool. And check this out. With just the one fan, it seems to hold the temperature pretty good. If I shut it off, fan still works. So that way it'll cool even when the engine's not running. And it'll shut off automatically when that switch shuts off, so we should be doing alright. Cool. I'll have to look at the wiring a little bit. I think I need a diode somewhere. There's a bit of a glitch. When I hooked up this second fan over here to the first fan, it's plugged into the high mode. And for some reason, when the relay's in, the high side comes on. So I'll have to look at my diagrams again and figure out why this thing is grounding out. I don't know. Something to look into, but we're almost there. Okay, so I had to make one little update to this. I had to add a diode right here because for some reason I'm getting some backflow through this relay. And I'm not sure why, because if I probe this terminal 85, the orange wire, with the ignition off, sometimes it goes to ground, sometimes it doesn't. I'm not sure what's up with that. So I'm putting a diode here so that the high side of the fan isn't being activated through this. And looking on here, it might have something to do with the AC relay over here, because this is our current path right here, and from here to here we're fine. And I don't think that wire is even in this system anymore. If it is, it just goes directly here, so it's not technically in that loop. But for some reason on here, we got two diodes here. It's a diode assembly, so the flow shouldn't be going through there, but for some reason I guess it is. So either one of these things over here is grounding out, or maybe something over here is grounding out, or I don't know what. But something is grounding out and allowing that fan to run when it's not supposed to. So by adding a diode down here, it should prevent flow through everything and keep everyone happy. So in order for that, I used my multimeter to see how much amperage the relay takes on the coil side, and it only takes 0.3 amps or 300 milliamps, so that's damn near nothing. So just going through my my diode bin, I have some 1 amp diodes. This is a 1N4001, so it's rated up to 1 amp, and we're not going to be using it for nearly that much. But it's got a 50 volt working limit, so we should be okay on that. And this was just a a regular assorted pack from Radio Shack, so that'll do what we need. So I'm going to put that in there, and hopefully that should fix our issue. Now, obviously, since this is a diode, it only allows current to flow in one direction. So, because of that, that means that the polarity matters. So we need to put it in the proper direction. Now, what we're trying to achieve is what we want the relay to ground to the switch, but we don't want the switch to ground through the relay. So we want to come out of the relay and go to the switch. So that means it's going to start on the green is our positive, and our black is our negative. This little white, this silver strip denotes, I think, the cathode, if I am using my terminology right. So this is going to be the end. So that strip is like the negative. So you want to make sure that this side is going to our black, because we want it to come out of that. And then the green will go to the other side. So we'll just solder that up. Let's not forget our heat shrink, and we should be doing good. Okay, so our little diode has been installed. Beautiful. Trim the leads. And I got the heat shrink ready to go. I just want to do some tests. So, first, we're going to probe this terminal to ground. So that's being grounded. That's the issue we've been having. So that means that if I plug this in and the fan doesn't come on, the diode's working. Look at that. Cool. So, the diode has fixed our problem. Now we're not having any weird starting issues or, things, the fan turning on when you turn the ignition off and weird shit like that. So, awesome. Still more poking about with this goddamn electrical switch. This factory fan is just kicking my ass. I've been noticing once the switch does hit the high side that this fan still doesn't come on. The one night I even tried jumping the relay. I tried jumping the ground side of the coil to the body, and it wasn't coming on still. So that means that the switch obviously wouldn't be able to do anything either if I was taking it out of the loop. So I'm wondering if all this bullshit right here is fucking with us. I don't know. I've tried dicking around with it. I tried adding a diode, and it's still not working for me. So I'm going to take this ignition side out completely, and then I'm just going to run 85 straight to 30, because 30 just gets hot at all times. So essentially what I did is I took that original orange out, I put a new orange in, and I'm just running it to the red. So I'm probably going to cut and splice this at some point, but just for testing purposes, now this is getting power. And if we jump our switch over here, this is with the ignition off. Now both fans work with the ignition off. So this should fix our problem. If this doesn't fix our problem, I don't know what kind of fucking next level gremlin shit we're dealing with, but it's gonna piss me off. So hopefully just jumping that coil side to direct positive will take out all this other bullshit and, fix our problem. Alright, so we got our splice now. Slide our heat shrink tube over and call this a done deal. No more dicking around with lighters. Now we got the real deal. Oh, don't be that asshole. There she goes. Yeah. Oh, that's really hot. Sweet. Heat shrink that motherfucker. Alright, so I know this video's been very long, but I figured I'd show you the revised version of what the diagram looks like. So this is the final setup for now, and it seems to work, so we're going to stick with it, you know. Just got hot at all times. It goes through the XJ fan relay to the XJ fan grounded. Volvo relay pack does its stuff. Everything gets grounded through the switch. And here's the diode, but I don't know if that's necessary anymore now that we fixed our issues up at 85. But, you know, that's how I did it. This will run all the time when your key's off, so this won't shut off until the switch shuts off. So if you want that to be different, you could put a relay up here to activate this or figure out some other stuff. So I don't know. I may do that, I may not, but for now, I'm happy with it. So that'll be the final hoopla for that. So I've got to try this out for a little while, and it seems to work rather well. So now I can push this thing for a little while before the temperatures start to creep up, and even then, you know, the temps do go back down. So I think about the only thing I could do now is put in a transmission cooler, and I'm probably going to do hood vents at some point if I can find some that I like. But yeah, that's how you hook up yourself a fan switch. That's how you make a 2-speed fan work automatically without having 2 different sensors, and all that crap. Now, the only thing that I don't know what to tell you is if you don't have a thing down here in your radiator, and the newer models, I believe, don't. You'll have to get a little bit more creative. I've seen people put adapters into their hoses, so you cut the hose and put in like some kind of metal, like just coupler, and then thread a switch into that, and you can put that in the high side or the low side, and stuff like that. But, you know, this is how I did it, so hopefully you've learned something. Hopefully I haven't been blabbered on too long, and hopefully you've realized that electronics can still be a major pain in the ass. So, you know, that's that. Alright. Stay cool, motherfuckers.